Hi folks. So I had an email question about extra practice problem for Module 3, number 7. So I'm going to work through this on a video just to make sure everybody feels comfortable. So it says this: if you react 12.0 grams of carbon with 4.0 grams of hydrogen, you will make methane with no leftovers. So you can see that by mass, you use more grams of carbon than you do of hydrogen, right? So if a chemist reacts 50 grams of carbon with 50 grams of hydrogen, how many grams of which element will be left over? So we can answer the first question, which element's going to have leftovers first, right? So you can see that we're going to think about proportions, right? 12 grams of carbon, only 4 grams of hydrogen. So if we use 50 grams of each, think which one is going to be left over. Clearly, we're using more by mass of carbon than hydrogen. So we're going to use more by mass of carbon. That means we're going to have some hydrogen left over, right? We need much less in grams hydrogen than carbon. So we want to do our math based on the carbon because that's the proportion that we are going to be able to relate here. So we know the recipe for 12 grams of carbon, right? We know the recipe for that. We know that we would make 16 grams total if we use 12 grams of carbon and 4 grams of hydrogen. We'd produce 16 grams of methane because mass can't be created or destroyed, right? So we're going to make a proportion here to figure out how we're, say, doubling or how we're expanding the recipe, right? If we doubled the recipe, we'd use 24 grams of carbon. If we quadrupled the recipe, we'd use 48 grams of carbon, but it's a little more than that, so we got to use a proportion to figure that out. So let's see, we're going to do 12 point, it's hard to write like this, hold on, 12.0 grams times some proportionality constant equals 50.0 grams. All right, so if I solve for x would be 50.0 divided by 12.0. Both of those have 3 significant figures, so I can keep 3 significant figures. So that's going to come out to 4.17 as my proportionality constant, which makes sense because we figured out if we were going to make 48 grams of carbon, we'd quadruple the recipe, times it by 4, right? But 50 is a little bigger than 48, so we're timesing it by 4.17. So instead of doubling the recipe, we are 4.17 timesing this recipe. So then we can just use that proportion to find out how much hydrogen we're going to use. So we know if we used 4.0 grams of hydrogen, we could make 16 grams of methane. So we're going to multiply that by this proportion, right? The doubling the recipe kind of proportion. So if I did 4 times 4.17, I already pre-did it. This has 2 sig figs times 3 sig figs. I'm only allowed to keep 2 because of that. So I get what rounds to 17. My unit's grams because this still has a unit of grams. This has canceled the units. This gram canceled that gram. So there's no unit for the proportionality constant. Can you see that decimal? So I'm going to end up with 17 grams, and that was of hydrogen because this 4 grams was of hydrogen up here. So then it asks how much would be left over. So if I use 50 grams of carbon, I would only need to use 17 grams of hydrogen. But I had tried to use 50 grams of hydrogen. So here's a sig fig challenge. 50.0 grams minus 17 grams. So you can see I've got out to the 10th place for significance here, only to the 1's place here, right? So if I do this subtraction, 10 minus 7 is 3, 4 minus 1 is 3, but I have to round to the 1's place because this limits my significance to the 1's place. So just 33 grams of hydrogen left over. Right, so that's my final answer. hydrogen will be left over, and I'll only need 17 grams of hydrogen to react with 50 grams of carbon, so 33 grams will be left over, and the sig figs were a little bit tricky, but we stuck with those. So hopefully that'll help you with Module 3 Extra Practice Problem 7, and I'll see you all Tuesday. Ask more questions by email, and I'll answer them.